Okay, so welcome to the ELEC 1013 network cabling course for the winter of 2025. All right, so you can notice that last night I just changed the banner so you can have some visual recognition of that. So it's easier for you to just jump on when it comes to choosing the icons on your laptop or tablet. All right, so that's what's going to be. Now, here is well, this is the first time we are seeing each other in theory class. All right. So it looks like the theory classes are organized in such way that there's groups, two groups, there are two groups, 1, 3, and 5, that's one group, and the group sections 4, 2, 4, and 6, that's the other group, okay? And it's organized in a way that each group is going to have 1 hour online and 1 hour in-person class. So everyone is going to get 2 hours of lecture materials, plus, excuse me, plus 2 hours of labs each week. So this lab class is not divided into subsections. You come to the lab every week. All right? And as far as labs, we are getting the instructionals in person during the labs, so I'm not going to repeat that. However, if somebody has any kind of questions, please ask away. Now, so this is the main screen here. Here's the announcement. That's your second semester right now, so you know what's going on. Here's my welcome message, and I'm going to leave this link here somewhere in the announcements. If there are too many announcements to fit in one sort of designated screen space, you might want to press this button here that says show all the announcements to get, because that YouTube playlist, this is, for example, this video right now, this Zoom lesson is recorded, and that video will be posted on that YouTube playlist. That's our playlist. And if there's anything else that I want you to know or see or anything, sometimes I'm going to make a video myself, and sometimes I'm going to point you to some sort of a short link or something like that. Now, as far as the professors, Professor Bach, that's me in all my glory here, and I will be doing the theory and labs. I think sections 1 and 2 or 5 and I forgot what it was. I'm still learning my schedule. Then Mr. Habinsky is going to do labs as well, and Professor Bailey as well. I posted their names and their emails should you want to contact them. Right? Now, as far as the way things are organized, here is content, and if you go into the course outline here, you're going to see our course plan, which is the second file right here. That's the one. You can download this file. Everything is explained, and you can look at the dates and the weeks. So if you don't know which week you are in a whole semester, you can go to our course and look. Okay, so for example, what's today? Today is January 9th. Oh, we are week 1. Orientation, safety, and whatnot. And next week, we're going to start second week of the semester. Those weeks will go fast. And here is the first hour, here's the second hour, and sometimes I have one topic for both hours, which is, well, like for example here, there's a lot to talk about here. All right, so that's our roadmap to success. If there is anything that changes, for example, there's a snow day or something like that, things might shift. But this is the initial plan. For the most part, usually we're able to adhere to this thing here. However, one way or another, you're going to get the whole content. All right, so that's that. Now, again, let me just go back to the screen here. There are splash screen. I'll try to keep the announcements to. I'll try to keep this area clean, and if there is any kind of announcement that is of a greater importance than others, I will have an archived tab with the announcements, and I'll show you where it is if there's a need for it. All right. All right. So if we go to content, okay, let me make myself look like a student. Okay, go into content, and here is another tab here. So student items, student resources. And I'm going to collapse all of them. The student resources has 3 subfolders. One is the blank work orders. If you click on that, you can see work order number 1. This is the work order for the labs for you to print. Just print a bunch of them and have them in your bag or in your locker, so you don't have to look for to print. Now that's the work order that we are going to use the most. Here's work order number 2, which is going to be only used for the coaxial lab, and we want you to use that second one for the coaxial cable lab. But that's the last, it's going to be one of the last labs. Right? I'm going to collapse that. And here is the labs. Here is the lab 1. This will keep getting populated with the labs. And here is theory. And over here it's not lit up yet because I made that available at 2 o'clock p.m. today. So at 2 o'clock p.m. today, January 9th, this will become a link for you to click on, and you can download the presentation that you're going to receive right now after we go through this little showing the ropes kind of a thing. All right. And by the way, is there any questions? Just as I said, pipe in on voice if you want. That's fine, or type it in the chat line. Occasionally, I keep looking at the chat window. All right, so let's not prolong it. We only have 1 hour for this, or maybe 15 minutes. Well, actually, 40 minutes now. Okay. Here is our PowerPoint presentation, Introduction to Telecommunications. Yes, we're going to have to introduce you to this. There are 2 types of telecommunications unofficially that I recognize. One is with the usage of antennas and radio telecommunications. That involves, yes, antennas, transmitters, receivers, and that has to do with the radio wave science. The other, as I unofficially, so don't quote me on that, but I just sort that thing for myself, and you might want to do that as well. I call it the modern telecommunications, and please, I use that term loosely. That has to do with the relatively newest way of the progress, as far as the progress of the technology. Like, for example, what I'm saying is that in 1990, sometime before 1994, or in early 90s, there was no data per se. Yes, there was data communications, but the computer networks were wired completely in a different way, in a way that is pretty much obsolete right now. It was using coaxial cable and the tap outs, using a bus system, which we will study what it is, because the bus system is still used in a different sets of equipment. But the modern type of communication that I recognize right now is everything relies on the Ethernet. excuse me, I just touched the microphone. It relies on the Ethernet connections, Ethernet protocol, Ethernet cables. So you're talking Cat5e cable, which is still kind of going on. However, there are tendencies to switch to Cat6 minimum or Cat6e or Cat6a minimum. So that is going to be one of the main players in our course here, and we will talk about and have hands-on experience on terminating certain types of terminations, connecting wire management as much as we can. We are going to go through a lot of cable this year, this semester here. Right? So as far as tools, I don't even have to show any pictures because I need you to bring for the labs. Please bring the side cutters, just the basic thing, side cutters or wire cutters, and don't use those little tiny ones that you get for your electronics lab. That on one side you have side cutters or wire cutters, and on the other side you have like a wire stripper. Those are too small. Go to any kind of a cheap store and buy yourself something that's called a power grip, which is power grip stands for just the regular size. Side cutter, at least have that. All the other tools, such as punch down tools, strippers, anything else, tape, electrical tape or the jacks and cable, it will be provided to you. But at least bring yourself side cutters. You will need that. That's going to be the main tool. If there's any other thing that maybe we'll need a little tiny miniature screwdriver, which I doubt, but as we go along, you will see what possibly you could use as tools, and you'll, as time goes along, if you decide to go into this kind of business, one by one, you will know what tools to buy. But again and again and again, I said, just bring your side cutters the regular size, which is called power grip. All right, so introduction to telecommunications. Telecommunications is basically telecommunications. Let me fire up my laser. Yeah, there we go. There's a red dot, which should be, you should be okay with that unless you are a cat. Then this red dot is going to make you nervous. Okay. All right. Tele over a distance. Communications. Communicating over a distance. All right. There are various different ways of communicating over a distance, over a longer distance. Humans, as long as we exist, we always try to find ways to send messages to each other. And you're talking anything from long time ago, so from sending homing pigeons with a little message attached to their leg. In Africa, there was a clever way that there was those drums beating the drums, tantrums. That was before electricity was invented. So that was a clever way of communicating messages from one village to another by drumming. Now over here, where we are, the native population used smoke signals, which is also a clever way of communicating. Well, this is not an anthropology class. However, sometimes it doesn't hurt if we touch on that, that kind of stuff. Later on, military, there will be waving flags, flashing lights, Morse code, and whatnot. And finally, we got into such advanced ways of communicating that we can communicate over a distance using this kind of state-of-art equipment. And I'll give a candy to the first person who names that movie that this thing was from. Nobody? Okay, no candy. All right. We will. There we go. Blues Brothers. Good, good, good. McCoy. Yeah, you're going to get a candy from me next time we see each other, provided that I don't forget. Okay, good. All right. Let's take a look at the basic telecommunications model. Communication over a distance, that's telecommunications. Let me get the red dot out of there. Now, over the means known to us these days. Well, we're talking about email, which is what's happening here. Why am I not having my? Okay, there's my mouse. Email is probably one of the most popular ways of communication. Fax, it used to be really popular late 90s and 2000s. However, still, some government institutions, they still ask you to fax things, just as if everybody at home would have a fax machine as they used to have 20 years ago. So get on board, guys. Here's my message to you. One of my messages. Pots. Communicating with pots, man. No, that's not those kind of pot. This is not kind of pots. Plain old telephone service, officially called acronym POTS. It is the most basic telephone service that you can get. Quite popular since Mr. Alexander Graham Bell invented the telephone and put that to use. Telegraph, telephone, up till now, POTS lines are still being used. However, they're being pried out by other means of communications like fiber optics, for example, and internet or Ethernet protocols or other ways, protocols for communications. However, POTS are still, the phone lines are still being in use. However, some of the equipment uses POTS protocol. Not going to get into it, but when you're talking interfacing telephone systems to other devices, such as PA system interface, then they use POTS protocol as well as far as signal, and we are going to talk about that a little bit more in detail when we get to it. VoIP, this is the more advanced than POTS. Says voice over IP, voice over Internet protocol. Then it sprang out quite vigorously after POTS in the last 10 years. There was a huge boom in business. However, even VoIP slowly is becoming the usual thing, and maybe there's some other choices made by companies. We'll talk about what voice over IP. It's the phone over internet. Right? Now, other ways of telecommunications, video conferencing, radio, television, okay. Internet, intranet. The difference between those two is that internet is globally wide, global, and intranet, it's just like internet, but it's within a small setting, like within a company. It was popular some time ago, and still by choice, but we're going to concentrate mostly on this thing here, POTS, VoIP, Internet, and LAN, which is local area network type of system. Basic communications, I lost my clock. All right, we're good, we're making good time. Basic model, you're going to see in different books, different model, which is going to be basically something like this. There is going to be something that is going to receive our input, like for example, the microphone that I'm talking to, it is an input transducer. Ooh, it's a very intimidating type of a word. Transducer must, if you're talking transducers, you must be really smart. Well, I actually am. Okay. Input transducer. What's a transducer? A transducer is a device that converts one form of energy to another form of energy. Do not confuse that with media converter. Media converter transfers transfers one form of signal to another, but a transducer transfers one form of energy to another. Like, for example, when I'm talking to this microphone with my mouth, I am causing the air to vibrate, causing the air to go into some sort of longitudinal waves. Those waves are going to hit the membrane of the microphone. The microphone membrane is going to convert the mechanical vibrations of the air into the electrical energy, right? So that's a transducer. And it's basically on the input and it's on the output. Now, then we have different type of signal processing and a transmitter. So I just put that in one box just to make things simpler. We'll talk more about that. But the signal that is being created then is being processed and transmitted over the medium. And for our mediums, we have two choices, basically: over the air, radio waves, or wires. Now, the wires can be copper, or they could be fiber optics. Then that signal has to be received somehow. With some sort of processing. So there could be another system within the system, as an input transducer can be put right here, as for example an antenna. But I just simplified that. So the signal is going to be received by a receiver, and it's going to be processed, and it's going to be shot into the output transducer. And for our purpose, for example, the output transducer within our communications system, that as we speak right now, the output transducer for you is the loudspeaker, which is the name for a speaker, or headphones. That's your output transducer. It converts one form of energy into another. This transducer that you have on your end receives electrical energy, and it transfers that into the mechanical vibrations of the air. Woo! Right. Just a little bit more details on these stages right here. Transducer example: it could be microphone, it could be loudspeaker, it could be antenna. Microphone converts sound waves into electrical energy. Loudspeaker converts just the other way, electrical energy into sound waves. Antenna converts electrical energy into electromagnetic waves, and vice versa. So the antenna is considered bidirectional type of transducer. It can receive or it can transmit. That loudspeaker and the microphone, they also are bidirectional. However, when it comes to the physical construction of a microphone, it is the most efficient as an input. Can you hear sounds through a microphone? Yes. If you put a signal to a microphone and you put your ear to a microphone, you will hear. Excuse me. You will hear sound coming out of them, but it's not going to be efficient way of communicating. Loudspeaker, it can be used as a microphone. In fact, sometimes when you remember being in high school, there would be those so-called high school PA systems. There would be there's like speaker station or intercom station somewhere by the door, and they would have a push-to-talk switch in the office. So the office would control which way communication goes on. So if the secretary in the office speaks, you cannot speak at the same time, because that was just one way communicating device. But did you notice that there was no any microphones around? It's because that speaker was used as a microphone, quite efficiently actually for that one. Signal processing. There are different processors. I just give you a little bit of a couple of examples here. Signal processor and transmitter, or sometimes we use the way it's called transceiver, which is a box that acts as a transmitter and a receiver. So we just combine these two words, and you go transmitter, receiver, i.e., transceiver. So over here we have a simple mixing board. Audio mixing board. It is a signal processor. It combines multiple signals into one output process, and with a little bit of processing that you could do equalization, or maybe adding some effects. Let's see if I can add some effects on this processor that I have here. Can we do that? Effects. I used to be able to do that. I guess I'm pressing a bunch of buttons. I forgot how to put effects into this one here. Okay. I'll show it to you next time. All right, now here is another transceiver. It's a wireless radio, and notice this one also has a microphone, push-to-talk microphone, and it's a two-way radio. You can transmit, you can receive with that, with this device here. So it's a signal processor. Now here is interesting signal processor. It is wireless access point, WAP. Generates wireless digital signal in computer network applications, and it is bidirectional for sure. And this one here that I just got the picture of is by Cisco. But there are other ones as well. I think in our schools we have ones by Cisco. Yes, we do. It is the Wi-Fi device. So very popular device. If you get into the business of telecommunications, for sure you will be hanging a lot of those. They're popularly called wireless access points, WAPs, APs, access points, same thing. And our one, the ones in our school, they have a light, and if you can read the light, you can see them all over the classrooms. More than one sometimes in the classroom, all over the hallways. The whole school is schools, hospitals, large buildings. They use that a lot. Sometimes just for the Wi-Fi communications, so you can log in. If you're logging into the school's network with your laptop or your cell phone, it is through that device. Your laptop or telephone connects to the first available or the closest one. Wireless access point. They have lights, and you can recognize the lights. If the light is green, that means nothing is connected to that specific access point. If the light is blue, that means at least one device is connected to it, because you can connect multiple devices. And if it's flashing, that means it's either booting up or maybe there's some error. So this is the, you can just look at that. If you walk into an empty classroom, probably you're going to see the light green on it if you look in the ceiling. And after about, I don't know, 30 seconds or so, it's going to change into blue because maybe it locked onto your phone. if you're logging into the school's network. So that's as far as signal processors and transmitters. Transmission links, simple. We're going to talk about air, copper, fiber. And this is the medium. Air is the medium for the signal. Copper is the medium for the signal, copper cabling, and fiber optic cabling. We will touch mostly these two, however, we're going to brush against that. Receiver, radio receiver, audio amplifier, wireless access point because it's bidirectional, so I also listed that here. Function of the receiver is to output signal process. It's the output signal processing, the output signal from the transmitter, the output signal gets and becomes an input signal for the receiver. Yeah. There are thousands of types of receivers, and we're going to touch on some of those as far as media converters, but we get to when we get to it. Over here, telecommunication system example, identify essential parts. Well, what do we have here? We have microphones connected, so that would be a transducer. And this would be a signal processing device. This would be also acting as a receiver and processing the signal. And this would be also acting as a transmitter because it shoots that to the amplifier, shoots that signal to another amplifier. Those amplifiers also have that system within the system. It has an input, processing, and output. So there are systems within the system. What do we have here? We have a wireless microphone. Here's a belt pack with a wireless microphone, and that acts as a system by itself here, acts as a system by itself here, and acts as a system by itself here. So there are those models that I showed you here. That model here is repeated several times here. Where's that slide? There you go. Now, just by looking at this thing, can anyone tell what type of a system it probably is? I'll give you a couple seconds here to think about. What type of a system is it? Where, in which scenario, in which setting it is probably installed? I need some like music. There's something that is almost like a dead giveaway for what type of a system this could be. That's if school gym, close, but there's something that is really, really almost a dead giveaway where this system would be probably used. But it could be used in the school gym as well. But there are a couple of elements that concert hall could be, yes, yeah. Studio, there you go. Jackson gets the prize. Church sound system. What's the dead giveaway? Choir mics. All right, there you go. Choir mics. So it is probably, but yes, it could be used in the gym, could be used in the concert hall, because concert halls, they also have choirs, right? But yes, this it's probably church system. Another, if you have an experience doing that, another almost a giveaway is this part right here. And it's a 70-volt amp. It's a distributed audio system. And that is used for something that's called a crying room. What is a crying room in the church? In the church, why am I mentioning this? Because this is a big, nice business. You can make a lot of money doing just the church sound systems all over the place. I've done it for years. And let me tell you, yes, it's a hard work, but as everything is, anything profitable, one way or another. But it's it's possible to make money on it and make a career out of it. Crying room in a church is like, for example, there is a service going on. The minister or priest or whatever the denomination is, I've seen pretty much all of them because of me installing sound systems in churches for about 10 years. Yeah. And during that service, somebody's baby starts crying. They do cry. When they're hungry, they cry. That's the way the babies speak to us. So, in order for, because as long as much as we love our babies, because babies are children and children are our future and so on, and we have natural tendency to love children as humans, unless you're a psychopath, then, but that's another story. But we don't want the service to be disturbed by the crying baby, because crying babies have that type of a sound that is hard to ignore by adults, because that's the way of speaking for the babies. It is supposed to be made in a sound that is hard to ignore, because that's the only way the baby can communicate. But if we're in a church, it's going to be annoying, So mom can just go into that something that's called a crying room, and it's behind the glass. So the room is enclosed. The mom can see what's happening, and there would be audio fed to that, so the mom can participate in the service still and can hear what's going on, except that the baby is crying is not heard in the rest of the congregation room. Right? So that's usually, and those 7-volt amps, those are the crying room speakers. Anything else like foyer or vestibules or hallways and anything like that, the system can be. If you are interested in that kind of stuff, talk to me. I'll help you with that. Whether is it something that you need in your church, then I can help you do that. Or maybe you want to go into that kind of a business, I can also help you with showing you the ropes of what you need to do. All right, what is involved? What is involved? We'll just go through quickly. Remember when we talked to you about those classes who already participated in the labs, we're going to talk about deliverables. With the deliverables, it used to be that you just get a piece of paper, write what you've done, and get the client to sign, and based on that, the client would be billed. Okay. Now everybody wants pictures as part of the deliverables, and we will tackle that during the labs. But these are a couple of pictures that years ago, not that long actually, maybe 9 years, maybe 10 years ago, when I was doing the service calls, and I got a call to one of the older areas of Toronto, and I was sent to identify line 1 and line 2 at the Tim Hortons. Well, nobody told me that Tim Hortons looked like this. It was a full-blown renovation. So I took the pictures and I said, look, I'm going to identify those phone lines. However, there's nothing you can do with that phone line right now, because it looks like it's not an operating store, restaurant. It's basically big renovation. So they're building things from scratch. And I took the pictures. So sometimes you're going to deal with that. I'll show you how to recognize those so-called BICS blocks. We will do some terminations. We have 2 labs involving those. This is an equipment rack that was at that Tim Hortons there at that time. And then I also took a picture, because once everybody went there, it was the people who sent me there, they thought it was just an operating store and they just needed to identify a couple of phone lines. But so I took pictures. So sometimes you're up against something like that. As far as data, you might participate in setting things like that. These would be these are Ethernet cables that are run, and this is that's a huge project. right? In fact, when we did Windsor PUC years ago, the amount of cabling would be half of that, and that was a huge project as well. But they also needed some fiber optics as well. So this would be equipment racks, floor-mounted equipment racks. Wires have to be pulled to location and terminated on this at this equipment racks on one-to-one basis, jack to jack, and those jacks later on are going to be patched or connected to other equipment such as switches, gateways, modems, and whatnot with the Ethernet cables. And I'll also show you how to recognize things like that and how to feel comfortable maneuvering around that. Notice that there is Velcro used to bind those Ethernet cables, no zip ties. You don't want to put any pressure on data cables. Now, what's involved in this infrastructure systems? The course is called network cabling, but I think maybe it could be called infrastructures. But infrastructures would be infrastructures of what, right? Are we building bridges? No. So maybe it's a good name for the course. What is involved? And these are just some aspects of it. Data infrastructure, that's huge right now. Running cables, terminating them, certifying them, qualifying them, giving the documentation to the client, ready for the IT people to use. Telephony, CCTV, closed circuit television, right now mostly associated with surveillance cameras or security surveillance. However, the CCTV, closed circuit TV, it's not just that. If you remember high schools, your broadcasting class, and there would be the TVs distributed over the classrooms. So every Friday, maybe your broadcasting class has a little bit of a newscast, or it would be distributed around the school through this closed circuit television system. Just trying to look at the clock here. We got a couple more minutes. Security alarms, nurse call systems. Nurse call systems are the ones that you have the kind of a button by your bed. If you need to call nurse, you press that button. They're complex systems. Fire alarms, you need additional licensing for that. PA, commercial, simple all-call systems or PA sound systems, it can get more complex. Like the theater sound system is way more complex than just a simple hallway annunciating system. Access control, quite often working together with security alarms. Access control, we got this card to swipe to enter, to unlock the doors and things like that. That's access control. Retail, huge. Everything needs to be wired. Cash register is a PC. PC needs to be connected to the network. And everything else, retails, they use cash registers, they use managers' PCs, they use computers, they use access points, they use telephony, they use intercom. Retail is a huge business, right? Systems, what do you need to know? You need to know working knowledge. So how do you get the working knowledge? Yeah, you're at the beginning stages of it now. Then how do you get the further knowledge? People who sell the equipment want the equipment to be sold. The equipment cannot be sold if people don't know how to install that and train the other people how to use that. So it's in their interest to approach the installation companies to train the installation companies on how to install anything that has to do with the new system or the existing systems that they have. So you will have a lot of on-job training by the people who are companies rep. Like, for example, Duquesne would send, they would organize sessions in their facilities about school PA systems and nurse call systems. Maxivox, they send reps. Even like Panduits, Ethernet jacks, specific so Panduit will send company reps to train the installers how to install their jacks. Fiber optics, you will get a lot of education after the education here. Setup, that comes with the experience and the education by the company reps mostly, or sometimes your companies, your employer might send you back to our school here because, to take maybe an additional fiber optic course or something like that, right? Commissioning is basically after the whole thing is being installed, whatever the system is, then you put on suit and tie and get people in the classroom, kind of a conference setting, and you explain the system to the people. Like if there's a new VoIP telephone system that was installed in a large facility, then you need to explain the features. This is how you make a call. Well, pick up the headset and dial the number, or this is how you make a conference call. This is how you use the voicemail in this particular, and so on. And service, ongoing service, knowledge of design of the systems, and sales. Couple minutes left. What else is involved in this thing? Data, a lot of data, and that's terminating and installing of the wiring. Telephony, I have listed here conventional phone systems, VoIP telephone systems, conventional use POTS, plain old telephone system for telephone lines, VoIP, it could be locally installed, main equipment, or hosted. We are going to talk about that in detail. And there are hybrid phone systems, because this would be a POTS phone system, this would be a conventional telephone system, this would be a VoIP telephone system, and sometimes you can install things between those to make it that work as VoIP. So that's what I call hybrid systems. CCTV, mostly surveillance. That's what's involved. Installation, service, big time. Security alarms, big lucrative business as well. Any of those that I'm showing you, if you put your full energy into it, you can make a career out of it. Nurse call systems. This is a demo set up by, we used to do Duquesne, but this is Roland, and there's also another one, Maxivox. And I think that's, I think it was Edwards once, but not sure if they do it or not. So there would be the hallway lights. This would be the indicators used by the staff. This would be the phones that are associated with that main console, pull stations, and all that is governed by a computer system somewhere digitally, and it has to be properly installed, properly set up, and serviced. Big business like that with this one here. Who's using that? Hospitals, nursing homes. Fire alarms, you need additional licenses. You might want to talk to Mr. Reekers about that, because our college does involve, our college has fire alarm education or fire technician education. School PA systems, that's an old one by Duquesne. Yeah, look at that, Duquesne here. There's a newer one after that. So in schools you could see something like that. So you could call it individual classroom. And the newer ones after that, the next generation after that was the you would have that console that looks like a phone on the reception's desk. This much smaller than that. All right, church sound systems. Church sound systems and church organ systems. There's a couple of techies setting up the organ. Over here and over here, there's something that's called tone chambers. Big room with speakers, loudspeakers, pointed all different directions. With the new technology, the new sampling, with speakers scattered all over the place, simulating a sound coming out of pipe. This is acoustic grill here. Even to a trained eye, you can't tell whether the organ sound is pipe organ or electronic organ. Right? There is money in it. There's business in that. If you have opportunity now, there's for church also. You have the spoken word sound systems as well. So there's two types of environments in one enclosed in one environment. All right. So I've done that for years. If you are interested in going to that, talk to me. I'll set you in the right direction. Distributed audio. These are speakers, hallway speakers or ceiling speakers. You can see them in Burger Kings, McDonald's, any kind of fast food places, schools, hospitals, everywhere. You can see them. and we have a system that I'm going to show you how to install. We have a lab just doing that. Stage audio, theater systems, gyms, school gyms. Somebody mentioned that, yeah. Just a good old portable rock and roll kind of a show setup, right? I've arenas, hockey arenas, conference rooms. This is basically acoustic grill right here. There's speakers underneath that or above that, and it's a whole complex system that involves rooms acoustics that play with the electronics that is installed. Fascinating subject. You can make a life career out of that too. Access control that needs to be installed, set up, and serviced. And this is the last slide. Retail, huge business. POS stands for point of sale. Here's a point of sale. Here's a there's so many points of sales here. Those wires have to be run to those because POS is a PC, point of sale. It's a cash register. It is a PC with a drawer connected to it. Everything has to be installed, connected, mounted, set up, and serviced. Ongoing service. I think that's the last slide. Yes, additional references. I have to list the references that we have. All right, so this is as far as this introductory kind of a lesson goes, and we're going to take this modern telecommunications part by part, and we'll explain some details, and we're going to enjoy a lot of hands-on activities. If you have any questions, because we're running out of time right now, please don't I can't speak anymore. Please do not hesitate. Send me an email. Talk to me in person. All right, and as I always say, I will see you when I see you. Thank you very much for your attention.